The amount of matter. You want to say something?
No.
The mass is the amount of matter in a body, or the quantity of matter in a body. The instrument used to measure mass is beam balance or electronic balance. The SI unit of mass is kilogram. The other units that can be used to measure
Yes.
mass are you can use gram, you can use milligram, you can use a nanogram, and what's not. So moving on, the next thing that we can measure is weight. The weight of an object. What this simply means is how much of the gravitational force is acting on an object or a matter. The amount of force that the earth crust is exerting on every object to pull it down is referred to as the weight of that object or that matter. Mathematically, the weight of an object is the mass of that object multiplied by acceleration due to gravity. Your acceleration due to gravity is approximately 10 meter per second square. For example, if you have a mass, or rather a matter, a particular object has a mass of 10 gram. Are you following?
Yes.
Has a mass of 10 gram, or let's say 10 kilogram. For you to know the amount, the weight of that body, what you have to do is to multiply the mass of that body with acceleration due to gravity. In the case of a body that has a mass 10 kilogram, just multiply it by 10 to give you 100 Newton. Then the unit of the unit of weight is Newton. Are you following?
Newton.
So weight is a derived quantity.
Yes.
We didn't do this in dimension of weight yesterday.
Yes.
So maybe from now you can do it on your own, maybe later.
Yes.
So going forward, you have time. We've talked about time, how to measure time. Time is the measure of how long an event occurs. That's what we call time. First, like measure time, we use clock, stopwatch, and the unit of time is, or the SI unit of time is seconds. So now,
Yes.
one common thing that a lot of people interchange with each other, which is wrong, is mass. Sometimes people confuse mass for weight. Mass and weight are two different things. Are you still there?
Yes.
So let us look at the differences between mass and weight. Mass is a measure of the amount of matter in a body,
Yes.
whereas weight is force due to gravity, the force that the earth is exerting on a body as a result of gravity. That's what we call weight.
Yes.
The mass is constant everywhere, whether you measure the mass of an object in America, in Sweden, in Canada, in China, in Nigeria, Venezuela, the mass will remain constant. Whereas for weight, the weight of an object varies with location, because the force that the earth is exerting on an object varies as a result of geographical differences. Then mass is measured in kg, while weight is measured in newtons. Hmm?
Yes.
Is that taken? So
Yes.
that brings us to the end of um, what is that topic? Introduction to physics,
Yes.
physical quantities, and measurements.
Yes.
Do you have any questions so far?
Yes.
Okay, what are your questions?
When you said as mass is constant everywhere,
Mhm.
is it a particular object
For
that can
example,
be
now,
found everywhere? That is,
no, that's not what it means. If I say, let's say now, you have kettle,
yes.
then you say you want to find the mass of that kettle. Kettle, that is the quantity of matter in that kettle.
Yes.
Normally, what are you going to use to like measure? You use the instrument for measuring mass. You have your what? What are they?
But this beam balance
Correct.
and electronic balance.
Okay, this your beam balance now. If you use it to measure the mass of the kettle, let's say for example, the mass of the kettle is like 2 gram, 2 kilogram, for example. If you use beam balance to measure the mass in Nigeria or in Lagos or in Abuja, it will give you
Yes.
2 kilograms. If you also take the same kettle, you take it to Kano, you want to measure the mass, it gives you same 2 kilograms. If you take the kettle to Ghana to measure, it will still give you 2 kilograms. If you take kettle, that same kettle to
Yes.
China to measure, it will give you 2 kilograms. Is that okay? So whenever you
Yes.
measure the mass of that kettle, it will remain the same. That is what we mean by that. That the mass of an object or mass of matter remains constant irrespective of the location that you are measuring it or that you are conducting the measurement.
Okay.
So now, can I ask you my own questions?
Yes.
When you want to measure using a ruler, what error should you
Yes.
make sure to avoid?
I should not look at the ruler from the side.
Or at an angle? That's correct. We call that error what?
Hmm?
That error, what do we call it?
I don't know.
I told you yesterday. We say error due to parallax.
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 That's correct. So now, how would you measure the volume of, say, how do you measure the volume of what?
A stone.
Okay, tell me, how would you measure the volume of a stone? Explain to me.
Through water displacement method.
Explain.
Okay. Why? Hmm?
Explain.
What? Why you put a stone, a water in in a container contains a particular matter. So when you put to find out the mass of the stone,
We are
water
we are
inside
looking
the
for volume of the stone, not mass.
Oh yeah. To find the volume of the stone, then you put the stone inside the water. And when you put the stone inside the stone will sink and the water will rise. So that's why the particular place the water rises to is due to the amount of volume inside the stone.
Mhm. Displaced by the stone.
They are displaced by the stone.
Continue.
So then that will be the amount of volume inside in the stone.
Okay. So how do you now determine that volume differences?
From the point the water was without the stone to the point the water became when the stone was put inside.
I believe what you are trying to say is that the initial volume of the water inside the container, what you do is you subtract the initial volume of the water without the stone minus the final
Yes,
volume of the water with the stone. I mean, sorry, from the final volume of the water with the stone. Is that correct? Are you following?
yes, yes.
So that brings us to the end of our last topic. We can proceed to the next one. Can you see the board?
Yes.
What did I write?
Please excuse.
Okay.
Sure.
Look at me. Look at me. So now,
Motion.
when you woke up this morning, what did you do?
I stood up,
Mm-hmm.
but I stood.
What did you do?
Eh?
What did you do?
I stretched my body first,
Mm-hmm.
then I stood up.
Mm-hmm. Continue. Continue. Is that all you did since morning?
Then I went.
Nam, stop laughing, please. Is it funny?
Then I went outside. Eh?
Is it funny?
Yes.
Okay.
Then I went. Then I went outside to perform ablution.
Okay.
Then I prayed.
Pause. Pause.
Then
Pause for a minute, please. You stood up. Let us look at all the actions that you did. You stood up. You did what? You stretched your body. Then what again?
yes,
What again
I
did you do?
stood up. Okay, then I went outside
Action. Action.
to perform.
You walked. Abi? Walking. Walk. Abi? So now,
Yes,
what do you notice? Matter has moved from one place to another. Matter, which is you move from one
yes,
place to another. When matter moves from a point in space to another point in space, this phenomena is referred to as motion. Is that not so? So now, in physics, I told you that we are going to be studying matter, energy, and how both of them relate to each other. If
Yes.
matter behaves in a particular way, why does it behave like that? That is what we are going to be studying in physics. So now, if matter has an inherent property to undergo motion, matter is performing motion, matter is moving from one place to another. We are going to be studying why matter is able to move from one place to another, or why it is even at rest. Is that taken? So what is motion?
Yes.
What is motion?
Motion is the process by which a body moves from one place to another.
Okay, okay, that's correct. So now we are going to be looking at types,
Of
types,
motion.
types of motion. The first one is random motion. Let's just say A, random motion. When do we say motion is random? If a body moves in no specified direction, at this moment it is going in this direction, the next moment it has changed direction. You cannot say that, or you cannot trace out the path that it is moving. That type of motion is referred to as random motion. It is irregular. The path of movement cannot be categorized. That type of motion is called random motion. Example of objects that undergo random motion. Have you ever like maybe used firewood to make fire?
Yes.
You have. Good. Do you notice smoke?
Yes.
So now, those smokes that you are seeing are, let's say, smoke particles. If you have noticed before, this instant the smoke is going like this. The next instant it has changed direction. The following instant the direction has changed again. So that type of motion is also called random motion. So we can say example of objects that undergo random motion. We can say smoke particle or smoke molecules. Any other matter that you can think of that undergo random motion?
Human being.
Human being? Oh, you can do random motion. How? Show me.
From an instant, I I move my head like this. And
Okay.
I'm going like this.
Okay. Actually, I'm not. It's not all human beings that can do it, but you can do. Let me add your own name there. Sekina can do random motion. Is that okay? Not only you. You can you can do random motion. Have you ever noticed bees buzzing?
Being.
Bee.
Yes.
You see their parts of light like this, like this, like this, like this, like this. Have you? So you can add you and B. You people are in the same category now. You people are doing the same random motion. Is that okay?
Yes.
How about dust particles? Dust, let's say sand. How about rice grains? when you throw grains in the air, their direction, some of the, or you just like scatter them, their direction is not very well specified. Or flower that is being moved by air or wind, or let's say dust grains under wind that is being moved by wind. So all these things, they undergo random motion. So let us put it, for example, this is the path zigzag. So this type of zigzag paths, any objects that undergoes them, we say they are doing random motion. E.g., Sekina, and what again? You're laughing. So let us move on to the next type of motion. B. Translational. Can you see?
Yes.
So now, when do we say a body is undergoing translational motion? If a body or matter moves from one point in space to another point, and that part of movement is called is a straight path. That type of movement is referred to as translational movement.
Motion.
Sorry, motion. Thank you very much. It's it travels or moves on a straight path. You say that movement or that type of motion is translational motion. So let us look at examples of translational or objects undergoing translational motion. Can you give me any example?
Car.
Car. Mhm.
Lorry.
Lorry. Any animals that you can think of?
Cheetah.
Cheetah. Mhm. One more example. I will help you because I know Sekina is always the zigzag that you can do. You don't want to do you don't want to do translational. How can't you do translational? Hello. Oh God. I still there. Welcome back. So now, Sekina, do you used to do translational or it's only zigzag you used to do?